Okay, welcome to dear learners. Today I am going to make a very short video on serial peripheral interface. So this is, again I am telling, it is not for the beginners who are handling with this SPI communications. It is for them only. So there is an assignment from some elevator companies that the elevator controller will work as master and it will send some data, and using SPI serial peripheral interface communication, we have to receive the data in a slave controller and it is to be displayed in Python GUI. So in my channel there will be a separate video how the captured data is to be displayed in Python GUI using, again there also it's a serial communication. So for that you need PySerial library to be installed in your laptop or computer. Okay, so I am just, because here I don't have right now the elevator, so I am using one more controller as master and it will be sending some data, and that I will be receiving in another controller which will work as slave. Okay, so first I will go to the connections. So this is the connections. So this is one Atmega 328P. I am writing these things in Arduino IDE. Slight modification will be there. You can write register level code, but for because as it is written in the library and it can be utilized, so that's why I am using those few libraries, few library functions. So this is the master. This is the master controller. Basically this will be there in the lift. It will be sending the data to the slave. This is the slave, and with the slave I have connected the virtual terminal through which I will see. So here you see I have connected pin number 13, 12, 11 and 10. So 13 by default it is for serial clock. You see it is written as SCK, and the pin number 12 it is master in slave out, and pin number 11 this is master out slave in, and pin number 10 it will be work as here it is defined as slave select. So when it will be low, that particular slave will be selected. Here we are connecting only one slave. Like that you can connect n number of slaves, slave devices. So that time your number of, say it will be 2 to the power, order of 2 to the power n. So if say there are 16 slave device I need to connect, then 2 to the power n means 4. So we need 4 slave select terminals. Okay, and in between you have to design one encoder, digital encoder, so which will, based on the input bit sequence, it will select that particular slave device. That I will slowly I will, in subsequent videos I will explain. Okay, so now coming to the master code. So here I am, as I told, I am using this header file called spi.h, and in the initialization I am using I am initializing that SPI protocol which is spi.begin, and this pin I am defining a pin number 10. As I told, I am defining it as slave select device, and by default it is, initially it should be high. That high means the device is not, the slave is not selected. Then I am initializing the serial communication. After that I am just, now I am selecting that slave device. To select that slave device, the slave select pin should go low. So that's why it is, I am giving low, and then I am transferring one value 81. Okay, through SPI protocol. And after because I have given some 1 second delay, that after completing the transmission, again I am making that slave select pin as high. That means again I am deselecting the slave device. Okay, but these things in this case, this will be already done. This job will be done by the elevator controller. These are the things already done there. Now coming to the slave code, again I am using this SPI.h, and here I am defining one byte called slave value received. The value received, slave value received, that means it is received from the master device. Okay, and here again I am using I am beginning the serial communication, and this master in, slave out. Okay, this pin I am defining as output. Here I am using one register called SPCR. Let us see what is that. So this is the SPI control register, and here other bits we are not using. I will be using only SPI and SPE, these two bits. So SPI, that bit is SPI interrupt enable. I have to, because I am going to use the interrupt. Okay, so here you see this bit, if it is high, then SPI interrupt to be executed if SPIF bit in SPSI register is set and the global interrupt bit is enabled. So already these things are done in that SPI begin I am using, so there everything is done. And to enable the serial peripheral interface communication, we have to make the 6th bit enable. So now if you see in the slave code, so 7th and 6th bit I have enabled, and as it is there the global interrupt to be enabled, so global interrupt will be there in the special status register 7th bit, so that's why I have made it high. Okay, and now I am going to interrupt service routine. So the interrupt vector for the that SPI, it is, the name is SPI underscore STC underscore vector. Now what I am doing, that the value received, that is I am getting from this SPDR. Okay, that is the byte I am receiving from the register. That means in the service routine, what it is done, whatever the value it is sent by the master device, it will be stored in that SPDR register, that I am capturing in a variable called byte. It is the data type is byte, and the name is slave value underscore receive. And in the while one loop, I am printing that and giving a delay. Here giving the character, because that will, everything it will come as ASCII. So let us see. So this is basically very simple code. It's a very simple code. You can see this is the code. It's a very simple code. Now I will run it. So for that, you see, in if you see the master code, I have given 81. So the 81 is basically capital Q. Okay, so now it should receive that capital Q. See, my PC is slow, so during total delay I have given 1.5 seconds. So you will be receiving that. This is a very simple code to handle, to receive the data from master to slave device using serial peripheral interface. So hope it will be useful to you. Any doubt, you can write to me in the comment section. Thanks a lot. Thanks for your patience.